Okay, so these ones are about triangles, and we're gonna put the sides and angles in order. So, and it makes sense. The large side goes across from the large angle, the medium side goes across from the medium angle, small side goes across from the small angle. I kind of like questions like this. I view it sort of like a scavenger hunt. You kind of have to look at what they gave you and go from there. So like, yeah, this says order the sides of the triangle longest to shortest. But I'm kind of going to look at what I have and just sort of go from there. So looking right here, they gave us this angle is 160. I know that the straight line is worth 180. So this little angle in here is going to have to be 20 degrees. So I know that this one is 20 because the straight line will be 180. I don't know what this one is. It has a variable in there. But this one right here, these are vertical angles across from each other. So if this one is worth 4x, then this one is also worth 4x. And that kind of gives us a problem to set up because we have the whole triangle. And I know that a whole triangle is 180. So I'm going to take these three and add them together to equal 180. So we'll have 5 plus x plus 4x plus 20 equals 180, and we'll go from there to solve for x. So that's back to like an algebra 1 kind of problem. We'll put the x's together. That'll be 5x, and then 5 and 20 is 25. So that's just combining the like terms. And then we're going to subtract the 25. And so that would be what, 155? And then divide by 5, and we're going to get 31. So we found x, that's good. I'm going to plug that back in to label all my angles, and here I'll use a different color for this. So we know this one's 20. If I plug the 31 back in for x, 5 plus 31 will be 36. So I know that one's 36. And then if I plug it back in here, 4 times 31 would be 124. So I have all the angles, and it said to put the sides in order. And you have to be careful because sometimes it's shortest to longest, and sometimes it's longest to shortest. So this one time we're going to start with the biggest one. So in this triangle, the biggest angle is this one at B. So the biggest side is the one across from that, which would be ED. So ED is first, comma, and then we're going to put the middle one. So 36 would be the next angle. So the side across from that one is BD or DB. It doesn't matter what order you write those in. And then the smallest one is the 20 degrees. So across from that is EB or BE, whichever you want to say. So this is putting the sides in order from biggest to smallest. The next one is similar, except it's asking for the angles. Oh, and it says smallest to largest. So it's the other way around. So first we need to find x, same as we did with this one. And it says the perimeter is 54. So if we add these all together, we're going to get 54. So I'm going to do 2x plus 4 plus 3x minus 8 plus x minus 2 and make it equal 54. And so again, now that's just basically like an algebra 1 problem. We're going to put all the like terms together. So for all the x's, 2x, 3x, and 1x will be 6x. And then 4 minus 8 minus 2 would be negative 6. And then we're going to add the 6 over. That would be 6x equals 60. And then divide by 6, we get x is 10. So I'm going to take that 10, again, I'll use a different color here. We're going to plug that back in and see what all the sides are. So 2 times 10 would be 20, plus 4 would be 24 for that side. Over here, 3 times 10 would be 30, minus 8 would be 22. And then for this one, 10 minus 2 is 8. And so it says to put the angles from smallest to largest. So I'm going to start with the smallest one, which is 8. If this side is 8, Then the side across from that is angle A. So angle A is going to be the smallest. And then 22 is the one in the middle. So across from that is B. And then 24 is the largest. So across from that is C. Weirdly, they went A, B, C. But they don't always go in alphabetical order. So you still want to actually do the problem. All right, this is one where it's like select all the ones that are true. So it selects all the sets of triangle lengths that would make a triangle. What you want to do is add the smaller ones. And if they're bigger than the larger one, then it's going to work. If they equal it, it doesn't. It has to actually be bigger. So when we look at this one, the two smaller ones are 3 and 4. 3 plus 4 is 7. That's not bigger than 7. So we do not want that. Roman numeral 2 is right below that. So if you add 8 and 15, that is going to be bigger than 18. So we do want that one. 11 plus 11 is 22, which is bigger than 11. So that one's going to work. That would actually be an equilateral triangle. All the sides are the same then. Here, 5 plus 7 is 12. That is not bigger than 16. 1 plus 2 is 3. That is not bigger than 4. And then 12 plus 15 would be 27. That is bigger than 18. So you just add the two smaller ones and see if it's bigger than the larger one. So what do we get? 2, 3, and 6. So that is which one is that? Oh, that's this one, C. Oh my gosh, my brain did something funny. See, I can do all the problems and then still pick the wrong answer because I'll just be like, wait, which one is it? So C is in coconut for that one. All right, and then this one's really similar. Two sides of a triangle are 55 and 20. We're gonna, again, select all the ones possible for the third side. The thing that gets tricky here, though, is you have to remember you're adding the two smaller ones. So if we have 14, it'd be 14 plus 20 would be 34. That is not bigger than 55, so we don't want that. 30 plus 20 would be 50. That is not bigger than 55, so we don't want that. 35 plus 20 would be 55. Again, that doesn't count. It has to actually be larger, so we do not want that one. 45 plus 20 would be 65. That is bigger than 55. What does that one say? Does that say 50? 60. Okay, so now here's where this is different. If that's 60, we're going to go with 60 for that. That's not one of the smaller sides anymore. These two are the two smaller ones. So we're going to add 55 and 20, which would be 75, and that is bigger than 60. All right, 72. So again, if you add these, you get 75. That is bigger than 72. If you add these, you get 75, which is not bigger than 75. Again, if it equals, it doesn't count. All right, so this is about congruent triangles, and these are all of your patterns that you can use. I guess we need to mark these triangles because there's nothing marked on here. Side, side, side would be if you have, all the sides are congruent. Side angle side means that your angle is in between the two sides. Angle side angle would be the side is in between the two angles. Angle angle side means the side is not in between the two angles. And then hypotenuse leg is only for right triangles. The hypotenuse is the one across from the right angle, and then one of the legs is the other side. So hypotenuse leg for that one. What I've always found tricky with these is matching up the letters correctly, like getting them in the right order. So this says A, B, C congruent to D, E, F. So they match up in that order. Like A would match up with D, B would match up with E, C would match up with F. So like they go in that order. So I know it says to find a perimeter, but the first thing we have to get is X. So I need to figure out which one of these sides matches up with EF. And the pictures aren't to scale. So you can't go with like, oh, it looks about like that. And this is tilted, so I have no idea which one it matches up with. So if I look over here, EF is the last two letters. That's going to match up with BC. So BC is this one, the 2x plus 10. And we're going to set that equal to the 14. So the hardest part is matching them up, really. Solving this won't be too bad. Just subtract 10. And then divide by 2. So we get x equals 2. but we're not done because it says to find the perimeter. So we're gonna plug 2 back in for all of these, and then add them all up. So if you plug in 2, 3 times 2 would be 6, plus 4 would give you 10. Over here, 2 times 2 would be 4, plus 10 is 14. It was actually silly that I talked through that. Obviously, it was 14. These ones match up. And then if you plug in 2 here, 7 times 2 would be 14, minus 2 is 12. And so we're just going to add those together. 10 and 14 would be 24, plus 12 would be 36. And it said to find the perimeter of DEF. I know it looks like I found the perimeter of ABC, but remember they're congruent, so it'll be the same. So it doesn't matter which one you're looking at. All right, over here, ABC congruent to DEF, find the location for point F. So again, we need to match them up. I have DE over here, and that's the first 2 letters. So DE is gonna match up with AB. So you almost kind of have to like, in your mind, like make this A match up with D and B match up with E, like almost twist this in your head. Like, I'm gonna twist it. The point we're looking for is gonna be like somewhere up here. And what I would do is kind of turn the paper and do a slope between these so I can count the little boxes. It goes right 2 and up 3. So from D, if we go right 2 and up 3, it's going to be right there. So kind of like pick the vicinity where you know it's going to end up, and that can even help you narrow down your choices. But that point is going to be 3, 5. I know that's like not a great explanation. Like, well, it was going to be right about there, and then I kind of just counted the little boxes, but you sort of have to like mentally twist that and be like, okay, the point's going to end up there. But you can also look at the other 3 and they won't make any sense. Like, for example, if you plotted 5, 3, that would be right here. Like, obviously those triangles don't look the same. So, you know, you can process of elimination. All right, here we're going to circle all of the ones. So we're going to get more than one answer probably, that you can do angle, side, angle. So again, that means the side is in between the 2 angles. So looking at this one, it says that this bisects angle WIS. If it bisects, that means it cuts it exactly in half. So we know that those angles are congruent. And then this side matches up, like they literally are right up next to each other. So we get angle, side, angle, which is the one that we want. So we want that one. Actually, if I'm remembering, like almost all of these work out. Here, these are vertical angles. So they are congruent. Vertical angles are congruent. And we have angle, side, angle. We're told that these sides are congruent. So angle, side, angle. So we want that one. For C, these little arrows on here mean that those are parallel lines. And so like the one that we did yesterday, you get all of like the alternate interior angles and everything. So we know that these 2 are congruent. So the ones alternate each other, and then these 2 are congruent. And I just put 2 lines on that one so that they don't all look the same. If you had a third one, you could put 3 lines on it. And then this angle, or sorry, not angle, this side is matched up. So we're going to get that as well. So I feel like that's angle, side, angle too, isn't it? Yeah, I mean, we have angle, side, angle. Actually, I think this is going to be all of them. Because if these are parallel, we're going to get the alternate interior ones. That's going to be angle, side, angle. And then this one's actually the exact same thing as we just did, angle, side, angle. So actually, it was all of them. I always feel like that all of the choices or none of the choices is a confusing answer. That always makes me like second guess myself, but they all worked out. All right, this is not congruent, but similar triangles. So congruent means they're like exactly the same. Like if you laid them on top of each other, they would match up exactly. Similar just means that they're scaled. So the example I always use is like if you have a keychain that's like the Eiffel Tower, it's like a scale model of the actual huge Eiffel Tower. So it's similar means they look the same and they're in proportion, but not the exact same stuff. So looking at this one, we're told ABE is similar to, that little tilde means similar to ACD, which is the larger one. So it's like the baby triangle and the mommy triangle is what I always call it. So which of the following is incorrect? So which one is wrong, basically? So we're gonna have to go through these until we figure out which one's wrong. So letter A, it says AB, which would be right here, matches up to AC. Okay, so that's the little one matches up with the big one. Equals, and then we have AE over AD. So again, that's the little one matches up with the big one. And then BE over CD. So again, the little one matches up with the big one. So this one's good, which means it's not the answer because we want the one that's incorrect. So let's try the next one. CA, that's the large side, matches up with BA. So it's large to small. And then DA matches up with EA. So again, large to small. And then CD to BE. So again, large to small. So that one's good. So it's either going to be that this one's wrong or that they're all correct. So let's see. AB is the little one. AC is the large one. And then, oh, this one's going to be wrong because this was little to big. And then AD is the big triangle and it goes big to little. So it's switched on us. So that's the one that's wrong. So it's little to big matches up little to big. And if they switch it on you, then it's not going to be right. All right. So same kind of picture as there. We have QST similar to QPR, find X. This is kind of nice when they just say find X. Oftentimes you find X and then you have to plug it back into something else. But once we get X, we'll be done. So we're going to set up a proportion like this. We'll have 3 over 8. So the little one matches up with the big one. So 3 over 8. And then when we do our equal sign on the other side, we again have to have it be the little one to the big one. So it would be X. And then the common mistake is people will just put 10. 10 is just this part, but we need the whole thing. And so you have to add them together and it'll be X plus 10. And that is tricky. That is tricky to do that, but just make sure you do the whole thing. And then to solve a proportion, we're going to cross multiply. So when you cross this way, you have to put parentheses around the X plus 10. So it'll be 3 parentheses X plus 10 equals, and then when you cross that way, it'll just be 8X. And then you're going to solve it just like a regular algebra 1 problem. So distribute the 3. It'll be 3X plus 30 equals 8X. And then subtract the 3X. We'll get 30 equals 5X. Divide by 5, and we're going to get 6. So D for that one. I guess the other thing you could do is test all the choices until you got the one that worked. But that wasn't too difficult of a problem to solve, so that was okay. All right, given ABC is similar to DEF, choose all of the following points that could work for point F. So again, the hardest part is matching it up. We have DE. That's the first 2 letters right here. So that matches up with AB. And I would try and figure out which one's the right angle. Like this is our right angle here. B is the right angle on this one. That's the letter in the middle. So that means E has to be the right angle down here. So B is the one in the middle. That's the right angle. E is going to have to be the right angle down here. So there's going to be 2 options for an answer. If this is our right angle, the triangle can either go like this and have a right angle there, or it can go like this. So your 2 points are going to be like somewhere over here and somewhere over here. So again, I would try to like eyeball that first, because then you can eliminate a lot of choices. And then the next thing is, again, I know it's not a great explanation, but we're going to like count the little boxes. DE is 2. And AB is 4. So what that means is this one is twice as big as this one. And so if I count out BC, let's see, 1, 2, 3, 4, 5, 6, 7, 8. BC is worth 8. That means down here it would be worth 4. It's going to be half as much. So if I count 4 spaces in this direction, that's going to put me right here. And if I count 4 spaces in this direction, that's going to put me right here. So again, the 2 triangles would look like this. Those are your two options for those points. And again, in my opinion, I think the hardest part is matching up the letters. Oh, but I think I counted wrong. 1, 2, 3. Oh, 4. I counted to 5. Whoops. This one. Thought that looked off a little bit. All right, make sure I counted right this way. So this one is -2, -2, and then this one is 6, -2. When you take the SOL, you're gonna have like a highlighter and all sorts of tools that you can draw on the screen with, so you'll be able to kind of like interact with the picture a little bit. All right, given this diagram, which of the following statements is true? These little arrows mean that these are parallel. So again, we're gonna get all of the alternate interiors. So these ones opposite each other are going to be congruent. And again, I just made one have 2 lines so you can tell the difference. And then actually these are also vertical angles. So the ones across from each other, those are congruent as well. So all the angles are the same. And so now we just need to match it up. They're going to be similar. We don't have any sides that are the same. So I know it can't be side angle side. So it can't be A or C. So we can get rid of those. We just have all the angles. And we just need to match up the letters correctly. So let's see, A, B, C. A is the one I labeled with 2 little tick marks. That has to match up with E. B is the one I labeled with 1 tick mark. That has to match up with D. So if we go A, B, C, it's going to have to go E, D, C. So that would be this one. Again, matching them up is the hard part, I think. Because like I can solve a problem like this all day long, but like matching up all the letters always like throws me off. All right, last one. Given this proportion, which would prove that the triangles are congruent? I would need to draw them out. And again, this isn't going to be to scale. I'm just like drawing a picture. Those don't look anything the same. I just drew 2 triangles. We want to show PQR. So I'm going to label that one PQR. Similar to STU. And now you want to make them match up. So I did P at the top. I'm going to need to do S at the top, and then T here, and then U here. So just make them match up. So we're told PQ, so that's this one, is similar to ST, or like is in proportion to. I'm going to put the little tick marks there. That's not actually accurate because that means that they're congruent, but just I need to show that those 2 match up. So just my note to self, I put a little tick mark there. And then PR matches up with SU. So again, they're not congruent, they're in proportion, but I just linked them up that way so I could see what was going on. Which angle would we need for to do this pattern? Side, angle, side. So I need the angle that's in between the 2 sides. So P would have to match up with S. And so that is C.